I'm ready to render my smoke element. I'm going to use the hardware render buffer, which performs multiple screen grabs, then averages the results into a high-quality image. In this type of situation, I'd render out two passes, a pass of the car with no smoke, and a pass of the smoke with the car as a holdout. I'm going to show you how to render the smoke pass, but first I need to cache my particles. To do that, I select the menu item Solvers, Create Particle Disk Cache option box. In the option window, I make sure the name of the cache directory will be the same as my file name. I may want to add a version number onto this value so I can process multiple simulations with different settings. Then I can load any of those versions into the current file if I need to show the animation supervisor multiple takes of a particle shot. Caching my particles makes hardware rendering much easier. If I render using motion blur, the cached particles will interpolate instantly during subframe evaluation. This is important if I'm using a blur by frame amount of greater than 1, where for every frame Maya renders, it has to step back or forward in the simulation a bit to calculate the next frame. If I don't cache my particles, I may get unpredictable results during a hardware render. I'll open the hardware render buffer and set my camera to Sprite Cam. Under the Windows Render Attributes menu item, I'll set a bunch of attributes, such as filename base, start and end frame, and resolution. I'm going to set my alpha source to luminance, which is usually a better way to generate alpha than the default hardware alpha method. Under Render Modes, I'm going to turn on Geometry Mask, which blacks out all geometry, yet doesn't add it to the alpha channel in the final render. This will provide the compositor with a sequence to layer over top the final car render. This element is being rendered for television, or 720 by 486 pixels. If I were outputting for film and my image resolution were to exceed my screen resolution, I'd have to turn on Full Image Resolution, which renders successive quadrants of the image, then assembles them automatically. I'm going to turn on multipass rendering using 9 passes. The more passes I request, the smoother the motion blur will be. The goal here is to get away with as few passes as necessary in order to keep your rendering times down. I'll also turn on anti-alias polygons, which will smooth the outline of the holdout a bit. Finally, I'll set motion blur to 0.6, which means the shutter will be open for a little more than half the frame. Motion blur settings will appear different depending on your resolution. I sometimes find that higher motion blur values are necessary at film resolution. You'll also have to increase the number of render passes, as your final element will contain much more detail. You don't want to see any stepping in fast-moving objects. Now, let's go to a frame with some particles and do a test render. I'm happy with the test frame, so I'm going to go ahead and start rendering the sequence.